Hi, good morning students. Today we are going to study on differentiation of BCA second semester. I am Buddhi Sapkota, your instructor. Here today we will be discussing on definition, geometrical interpretation, rules of differentiation and some of the examples related to it. Okay. For differentiation, you already have studied about the concept of limit and continuity, which are the basic tools for differentiation. So we use limit and continuity for doing calculations of differentiation. Differentiations are the concept used for everyday life activities. For example, modeling, use of differential equation in real life problem, modeling of heat equations, environmental problems, fluid flow dynamics, aeronautical space related problems, and so on. Okay. If you talk about the contributors, mainly Sir Isaac Newton, Leibniz, and many others have contributed for the initiation or development of the concept of differentiations. Today, just define what is differentiation. We'll check what is differentiation. You know that derivatives. So differentiation is the process of finding derivatives. So it is the process of finding derivatives. We find derivatives of different functions using different methods, tools or rules, we can say. So we'll be talking about the rules in this lecture. So how we find derivatives? Where are the applications? What is the geometrical meaning? Just we'll be talking about it. Okay. So when we talk about the definition, it is based on the concept of limit. Okay, let y is a continuous function, y is equal to fx is a continuous function delta y be small increment in y. Here y is dependent variable and x is independent variable. Delta y be small increment in y corresponding to the small increment delta x in independent variable x. Okay. So we have a function. It is continuous. It should be continuous. You have already studied about the continuity. So any curve, if you draw it without lifting, it says it is a continuous curve. There is no break. If there are some breaks, let's say this one, so it is not continuous function. Okay. So if y is equal to fx is a continuous function and delta y be small increment in y and delta x be small increment in x. In this case, first we see the increment delta y minus delta y is the increment, delta y divided by delta x limit delta x tends to 0. So this value, the limiting value of the ratio delta y by delta x is denoted by dy by dx. We write it dy by dx, that is derivative of y with respect to x. Okay, so it is denoted by, sometimes we write it as y prime or f prime because y is f, or df by dx. Sometimes it is also written as y1, etc. Okay, so this is the very simple definition. We'll check its geometrical interpretation. Let's talk about geometrical interpretation. Okay, so here this delta y, you can find this from this function. Suppose here y is given as f of x. So y plus delta y is equal to f of x plus delta x. Okay, so to find this delta y, you have to subtract equation 1 from equation 2. Is it clear? Okay, is it clear? Then if you subtract it, you will be getting y plus delta y. Delta y means y plus delta y minus y. These two y cancel. So this is equal to f of x plus delta x minus f of x. F of x. Okay. So first you will be given fx. It is given. Find f of x plus delta x. Then subtract f of x from f of x plus delta x to get this delta y. So here in the definition, delta y is to be divided by delta x. Now, if you divide it by delta x or delta y by delta x is equal to f of x plus delta x minus f of x divided by delta x. Okay, this is the ratio. This is the ratio of this increment delta y with increment delta x. Okay, so here you just take the limiting value. If you take the limit, you will be getting limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0, f of delta x minus f of x divided by delta x. Okay. So this is the basic definition. This is the basic definition or definition of derivative. This ratio is called dy by dx. Thus dy by dx is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Okay, so this is definition, or sometimes it is called first principle, or sometimes it is also called by initio. Okay, If you are asked to do some derivative by first principle, then you have to follow this rule, okay? And sometimes it is said by definition, find the derivative by definition, then you have to use this one. Or sometimes it says by initio, okay? For example, I'll just give you a very simple example. Okay, for example, if fx is equal to constant function, suppose c, we know that c is a constant function. So in this case, f of x plus delta x is equal to also c, because this constant function, if you see the graph of constant function, I'll just check it here. Suppose this is c. If this distance is c, then everywhere you will be getting this c. Suppose this is x. If this is x, f of x is equal to c. This is f of x. This is f of x. Okay. So if you go for x plus delta x, suppose this is delta x, then this point is f of x plus delta x. Okay. Then x plus delta x. So this value is f of x plus delta x. Okay. This height is f of x plus delta x. So this is the constant function. The nature of constant function is said. Okay, now, so I have to find the derivative. So how to find it? We use this definition. This one. First subtract this one. Suppose this is 1. Suppose this is 2. We know that derivative is defined by this formula. So use these two values here. So you will be getting this is equal to limit delta x tends to 0. What is f of x plus delta x? It is c. C minus what is f of x? It is c by delta x by definition. Okay. So these two cancel, is equal to 0. So what is the derivative of constant function? It is 0. That is y is c. Actually this is y is c. In this case d by dx of c constant function is equal to 0. So this is about the derivative of constant function. Okay. For example, if somebody asks you what is the derivative of 5? Derivative of 5 d by dx of 5. 5 is constant, so its derivative is 0. Okay. So this is the definition. So you know that the definition is dy by dx is equal to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Okay, this is the definition. You have to remember it. Okay, it is very important. We use this everywhere for first principle. We can write here definition. We use this definition. I'll just write the definition is dy by dx is equal to f of x plus delta x minus f of x divided by delta x. So you learn this, okay? Now we use what is the geometrical meaning, okay? What is the geometrical meaning of this derivative? For this geometrical meaning or geometrical interpretation. Okay, students, now we see what is the geometrical meaning of derivative. Okay, let's say here is a curve. You can see this y is equal to fx is a continuous curve. This curve from Q to P. You know, this curve. This is a curve. Y is equal to fx. Okay. Now we will be having geometrical interpretation. Okay. Let y is equal to fx be a continuous curve as given in the figure. Okay. Pxy be any point on the curve. This one, Pxy be any point on the curve. And Qxy, this is a curve, so you first take P, xy, then take Q very near to P. And Qx plus delta x, comma, this is x, okay, y plus delta y. This is the position. X plus delta x, this is x, y plus delta y, okay, this is delta y. B, any neighboring point. Okay, on the curve. Now, so here is a P, this is Q, this is chord PQ, okay, chord PQ, this one. So how to find the slope of the curve? Chord, you know that slope is defined as y2 minus y1 by x2 minus x1. So slope of chord PQ is given by y2, that is y plus delta y, minus y1 is y divided by x2 x plus delta x minus x1 is x, okay, x. That means, so y plus delta y is f of x plus delta x minus y is fx, okay, it is given f of x divided by this cancel, so this is cancel, it is delta x. Okay, now we are going to get some expression very near to derivative. Okay, then this is slope of chord PQ is equal to f of x plus delta x minus f of x divided by delta x. So in your definition of the derivative, there is a limit delta x tends to 0. It was there. So we'll be using that concept. That means approach that delta x tends to 0 means delta x means this distance tends to 0. This means this point comes in this way to this point L. M comes to L. In that case, delta x tends to 0. If M comes to L, that means Q points tends to P. That means whenever Q moves to P, in that case, the line, this line that was curved, converts into this tangent PT. Okay? This PQ converts into PT, that is tangent to the curve. So, when Q tends to P, in that case, the curve PQ becomes tangent to the curve. Okay, it becomes tangent to the curve. So in that case, delta x tends to, that is, in that case, delta x tends to 0. Delta x tends to 0. Now we use limit. Now, limit delta x tends to 0, delta x tends to 0, f of x plus delta x minus f of x upon delta x. What is this? This is equal to limit delta x tends to 0. What is this value? F of x plus delta x minus f of x upon delta x. What is this value? It was slope. Slope of curve PQ is this quantity. So this is slope of chord PQ. Okay, slope of chord PQ. I'll just remove it. PQ. Okay, that is chord PQ. So what is this? This is derivative. F prime x is equal to slope of the tangent. So dy by dx, that is f prime x, is the slope of the tangent at the point P to the curve. Okay. So this is the geometrical meaning. What is the geometrical meaning? The derivative gives us the slope of the tangent to the curve at the given point P. Okay. Now we move for some very simple rules for differentiation. This is geometrical meaning. Now there are some basic rules for differentiation. These rules, I will be talking about some rules. Rules of differentiation. First, there will be power rule. Number 1, this is a power rule. This rule can be obtained by using the concept of limit again, as I said earlier. Suppose if y is equal to x to the power n, if this is the given function, then dy by dx is equal to n into x to the power n minus 1. So this is the power rule. So what we do, whenever there is a power of x, and if you differentiate that function with respect to x, you should remember always that here should be x. If suppose this y is x, suppose you say y, if instead of y I can write x to the power n, x to the power n, okay. So x to the power n, here should be x, okay. If this is x, then n, x to the power n minus 1 is the derivative of this power. For example, derivative of x to the power 7 is equal to, what will be the value? 7 n x to the power n minus 1, that is 7 minus 1, this is 7 x to the power 6, okay. So this is the value, very simple. So if this function has any power, for example, if there is x plus 1 to the power 5, then you can find this derivative by using power law, okay, is equal to, this is x plus 1, so this is 5. Later on we will be using chain rule if there are some coefficient with x, but in this case you can just use x plus 1 to the power 5 minus 1, that is 5x plus 1 to the power 4, okay. So we'll be talking about other cases here, okay, chain rule, in chain rule, okay. So we can get the derivation of this rule by using the concept of limit, okay. So how we can get that concept here? Let y is equal to x to the power n. We use first principle for power rule, okay. Y is equal to x to the power n. Y plus delta y is equal to x plus delta x to the power n. Delta x is small increment in x, and delta y is corresponding increment in y, okay. Let this is 1, this is equation 2. Subtract 1 from 2. What you get? You will be getting y plus delta y minus y is equal to delta y is equal to x plus delta x whole to the power n minus x to the power n, okay. This is just difference. Now delta y by delta x is equal to divide by delta x both sides, okay. X plus delta x to the power n minus x to the power n divided by delta x. This is just dividing by delta x both sides. Then it will be equal to x plus delta x whole to the power n minus x to the power n divided by, this can be written as x plus delta x minus x. Okay, these two x cancel, so you will be living with delta x. Okay, so why I write this x plus delta x here? It is because we have to use the concept of limit. There is one limit. In limit we studied that the value of limit delta x tends to 0 x tends to a, limit x tends to a, x to the power n minus a to the power n by x minus a is equal to n a to the power n minus 1. So this we studied, okay? This we studied. So we want to use this one, this concept in this case. It is very similar to this one, except there is no limit. So first I will write limit, okay? Limit delta x tends to 0, delta y by delta x, limit delta x tends to 0, delta x tends to 0, this value. So these two are very similar. X, suppose x plus delta x, you say x to the power n minus a, instead of a here is x, x to the power a to the power n, x to the power n minus a to the power n by x minus a. Very similar to write this, okay? Now we use this, this value is equal to n a to the power n minus 1. That's why we can write it as n a. What is the value instead of a? X. X to the power n minus 1 by using this limit. Okay? By using this limit. So d by dx, what is the value of y? Y is equal to x to the power n. So derivative of x to the power n with respect to x is n x to the power n minus 1. Okay, so this is our power rule. Why it is power rule? Because it is the method is used to find the derivative for a function which has a power n. Okay, power n. Now I have already explained about the examples. So this is a power rule for derivative. Okay, so I hope you understood it. For example, again we can see example. So if you check the values, we can see. So this is y, this is dy by dx is derivative. So we can see different values. So how these derivatives are done. So x has a power 1. That means 1 into x to the power 1 minus 1. That is 1 minus 1 means x to the power 0. That is 1. That means it is 1. Okay. X cube 3x square. Okay. X to the power 3 by 2. What is the value? 3 by 2 x to the power n minus 1. 3 by 2 minus 1. 1 by 2. Okay. And so on. If there is x to the power minus 1 by 2, you have to again subtract minus. In that case, it will be minus 1 by 2 x to the power minus 1 by 2 minus 1. That is minus 3 by 2. So in this case, we can see the cases, okay, for power rule. Next we move for derivative of sum of the two functions, sum rule. Next, sum rule. If u and v are two functions of x which are continuous, okay, then sum of derivative of their sum is equal to sum of their derivatives. Okay, so this is a basic definition for sum rule. Let's say y is equal to, if y is equal to 3x square plus 5x, in this case you can take this as u, this as v, so u plus v. So what is the value of dy by dx? You can say d by dx. Just it says that derivative distributes over the sum. Okay, this derivative distributes over the sum, dy by dx of this function, then dy by dx of this function. It goes to both of the values. So dy by dx is equal to d by dx 3x square plus 5x is equal to d by dx of 3x square plus d by dx of 5x. Okay. So here is one rule for constant function. Just I will make it clear here. If you have any function multiplied by any scalar k, in that case this constant comes out. Okay, it is equal to k d e of x by dx. We can take it out. The constant can be taken out. So what is constant? 3, 5, these are the constants. So you can take it out. 3. So d by dx of x square is 2x. D by dx of x square plus 5 d by dx of x. This is very easy case. So it is very easy. 3 into by power rule, it is 2x plus 5. So derivative of x is 1 is equal to 6x plus 5. So how this derivative of x is 1, you know, because you are the students of BCA. This is a very basic concept. But if you don't know, then you can again use that power rule. Okay, power rule, again power rule. D by dx x to the power 1, that means n x to the power 1 minus 1 is equal to 1 into x to the power 0. X to the power 0 is 1, so is equal to 1. Okay, so this is sum rule. Now we go for product rule. Okay, now we move for product rule of differentiation. So it says that derivative of two functions multiplied together, u and v, by name you can say product means product, sum means addition. You know? So earlier it was sum rule, now it is product rule. Is equal to first function into derivative of second plus second function into derivative of first. So this is the product rule. We can derive this function as well. So how this rule we can derive it, and we can use it for different calculations. Okay, most frequently used. For example, if you have any function, let's say f(x) is equal to x plus 1 into and gx is equal to x. These are two functions. In this case, y is equal to f into g. So instead of u and v, I used f and g. So you can find dy by dx as very similar to this. If you take f instead of u, g instead of v, similar things will be happening. Okay, f dz by dx plus g df by dx. So f is given. So what is the value of df by dx? Df by dx is equal to, so let's here let's write it. F means x plus 1. Okay, d by dx of g is x plus g x into d by dx of f means x plus 1. Okay, very easy, very simple example I have taken to make it clear. Okay, x plus 1 into, what is the derivative of x with respect to x? It is 1 plus x into, so what is the derivative of x? 1 plus what is the derivative of, what is the derivative of x? It is 1. What is the derivative of 1? With respect to x, 0. Constant function. You know that derivative of c was 0. So this is c. Now it is x plus 1 plus x is equal to 2x plus 1. Okay? 2x plus 1. Now you can, I have written in this way in the formula. But what happens if you multiply these two? Then find the derivative. If you multiply these two, y is equal to f into g. This means x plus 1 into x is equal to, multiply it, x square plus x. Okay, y is equal to x square plus x. When you take derivative, dy by dx is equal to d by dx x square plus 1. Okay, what is the value of derivative of x square? This you can derivative of 1 x. Okay, what is just divide in both sides. Okay, distribute it in both sides. X square plus d by dx of x. You know, very basic thing. Okay, by power rule, 2 x to the power n, x to the power n minus 1, 2 minus 1 means 1, 2x plus 1 is equal to 2x plus 1. So both of these are same. Just you check it. Okay. So multiplying these two functions and differentiating it with respect to x is similar to using this formula used for product of two functions to find the derivative of product of two functions. Okay. So this is about the product. Just what you do, you take first as it is, differentiate second as it is, differentiate first. Okay. Don't be confused about u, v and f, g. Just if you write it here u and v, u into v, you can say if this is u and if this is v, it will be u and v. So again it will be same as u dv by dx plus v du by dx. Okay. If there are two functions, always use this formula, multiply it. If two functions are multiplied. For example, again you can see other examples as well. Suppose other example, let y is equal to x square plus 3x plus 5 into x cube minus 4x square. Whenever you see the multiplication, if you have to use that rule, product rule. So here you can easily find out the way. Take u is equal to x square plus 3x plus 5, v is equal to x cube minus 4x square, okay, du by dx is equal to 2x plus 3 by power rule, x square, derivative of x square 2x, derivative of x is 1, 3 is constant, so derivative of 5 is 0. 0 is equal to 2x plus 3. And what is the value of derivative of this v? dv by dx is equal to d by dx x cube minus 4x square is equal to d by dx of x cube minus d by dx of 4x square, okay, is equal to power rule n x to the power n minus 1, 3x square minus 4 constant, so x square derivative of x square is 2x, 2 into x, okay, this is into, so you can write it 4 into 2x, that is this one, dv by dx, okay, just you find these two values, then use the formula. Now d by dx of u into v is equal to, this is u is equal to u dv by dx plus v du by dx, okay, du by dx and dv by dx are already found, so just u and v are given, just put the value u, v and this form, you will be getting the answer, okay. U is x square plus 3x plus 5, dv by dx is dv by dx. If there is u, then v, okay? If v, then u, you have to use. dv by dx is 3x square minus 8x plus v, x cube minus 4x square into du by dx, 2x plus 3. Okay, then you just multiply and get the answer. Okay, there are many terms, you can just multiply each term by each term. Okay, term by term multiplication. By x square, just multiply these two, 3x to the power 4 minus 8x cube plus 9x cube by 3x we are multiplying minus 24x square by 5. If you multiply it by 5, then you will be getting 15x square minus 40x. Okay, now multiply these two. First multiply by x cube. What is the value? Plus 2x to the power 4 plus 3x cube minus 8x cube minus 12 x square. So this is the value. Just you add if they are similar and subtract if they have opposite sign. Okay, depending on the sign. 3x to the power 4. Just collect the similar powers. It will be easy for you. 3x to the power 4, 2x to the power 4. Are there other x to the power 4 terms? I think these two only. Okay, 3 x to the power 4 plus 2x to the power 4. Next 3 minus 8x cubed plus 9x cubed, then 3x cubed minus 8x cubed. These are similar. Then subtract, check the terms with 2 power. Minus 24x square, 15x square, x square, then 12x square. Okay, so these are the terms. 2, 4, 6, 8, 9, 2, 4, 6, 8, 9. One term should be there. 3x cubed, 14x, yeah, there is 40x minus 40x. Okay, is equal to, just add similar, 3 to 5, subtract from 8, minus 3 to 5 first, 5 x to the power 4, then 9 minus 8, 1, 1 plus 3, 4. 4 minus 8 minus 4. X cubed, then 15 minus 12. 3 plus 3, then minus 24. That is minus 21 x square minus 40x. So this is the derivative of the product, dy by dx. So in this way you can use product rule. Okay. Okay students, we studied some of the rules of differentiation. For next class we will be having some other rules like quotient rule, chain rule, parametric rule, and some functions. There are other functions in which we have to deal with. Okay, that are some implicit functions, explicit functions. Okay, so we'll be talking about these in next class. For today, you learned about basic definition of the derivative, geometrical meaning. That is, what is the geometrical meaning? It was slope of the tangent. Derivative of function at a point is the slope of the tangent at that point. So then you studied about some rules. For example, derivative of constant function is 0. That's why similarly derivative of power x to the power n is n, x to the power n minus 1. Then derivative of product of two functions, derivative of sum of two functions, then constant functions. Okay, these are the things we studied, and thank you for your patience. Thank you.